In this video, we are going to look at limiting reactants, which are sometimes known as limiting reagents. So the limiting reactant is the reactant that is completely used up in a chemical reaction, and it will determine how much product is formed. Once the limiting reactant runs out, the reaction would stop because it would no longer have one of the reactants in that chemical reaction. The excess reactant, or sometimes known as the excess reagent then, is the reactant that is left over after the reaction stops. In terms of solving a limiting reactant problem for stoichiometry, which means you need to determine which reactant is limiting, you're going to follow the same set of steps as in any stoichiometry problem. The first step is writing a balanced chemical equation. The second step is determining the amount in moles for each reactant. So this is slightly different than the other problems we've done so far because you're going to be given information about both reactants, so you need to figure out the amount in moles for each reactant here. You're then going to use mole ratios to determine the unknown mole value for each of the reactants. The smallest number that you get is going to correspond to the limiting reactant. And so then in your final step, you're going to use the limiting reactant to determine the unknown value and then convert to other units if necessary, and that is the same as any other stoichiometry problem. Let's look at an example then. We've got lithium nitride reacting with water to produce ammonia and lithium hydroxide. So 4.87 grams of lithium nitride reacts with 5.8 grams of water. What is the limiting reactant? So you're going to recognize limiting reactant problems because it's going to give you information about both reactants. To find the limiting reactant then, what we need to do is consider both of our reactants and then determine how much of one of the products in terms of moles is produced. And whichever one produces the smaller number of moles of that product is going to be our limiting reactant. So let's first look at lithium nitride. If we find the number of moles of lithium nitride, we're given mass. So we're going to divide that by molar mass, 4.87 grams. And the molar mass of lithium nitride is 34.83 grams per mole. And that gives us 0.1398 moles. And then if we use a molar ratio, we know 1 mole of lithium nitride produces 1 mole of ammonia. And so we calculated the number of moles of lithium nitride, and we're trying to find the number of moles of ammonia. And so because it's a 1-to-1 ratio, the moles of ammonia produced is 0.1398 moles as well. Okay. Now let's take a look at water and see how many moles of ammonia is produced from 5.8 grams of water. So again, same deal. 5.80 grams divided by the molar mass of water, which is 18.02 grams per mole. That is going to give us 0.3218 moles. And then we want to set up a mole ratio with water. So we know 3 moles of water produces 1 mole of ammonia. And we are given 0.3218 moles of water, and we're trying to find the moles of ammonia. So if we do this, you get 0.1072 moles of ammonia. Now here what you want to do is compare the two values. You take a look at if we use lithium nitride as our limiting reactant, we would get 0.1398 moles. If we use water, we get only 0.1072 moles. So that means that water is going to produce the smallest number of moles of ammonia, so it is the limiting reactant. And that means that the lithium nitride is in excess. All right, part B then says, what is the mass of ammonia produced? Well, we've already done most of the work here because we know if we use water as our limiting reactant, it is going to produce 0.1072 moles of ammonia. So to find the mass, we're just going to take moles times the molar mass. We got 0.1072 moles. And then the molar mass of ammonia is 17.04 grams per mole. And so that's going to give us two significant digits. We need 3 here, is 1.83 grams. So 1.83 grams of ammonia is produced when we use water as our limiting reactant.